Hello, this is Mario from Odeon. In this video, we will talk about wall types in room models. Wall types can be configured in the material list, which can be opened by clicking on this icon. On the left side of the material list, there is a column called Type. This refers to the wall type, and the options are normal, exterior, fractional, and transmission. The transmission wall type will be addressed in another video, so here we will talk mainly about the first three. Both in real-life problems and in an Odeon model, surfaces have different acoustic behavior depending on whether they are a part of the room's boundary, in which case they are considered exterior walls, or if they are part of objects in the room, in which case they are considered interior walls. Odeon decides what are exterior walls and what are interior walls based on a parameter called the interior margin, which is a distance from the boundaries of the room. Walls closer to the boundaries than this distance will be considered exterior, and walls further from the boundaries than this distance will be considered interior. Diffraction and scattering are handled differently depending on whether we're on an exterior or interior wall, so it is important to have it set up correctly. You can visualize what Odeon currently considers exterior and interior walls with the current settings. To do that, let's go back to the 3D view by clicking here. Then, press the T key to cycle through different views. For example, this view shows the interior walls. And you can tell by looking here at the top of the window and noticing it says interior mode. We press T again, and now it shows the exterior walls. Again, this is expressed at the top of the window. We can change the interior margin by going to the room setup. As an example, we can look at the effect of changing this parameter to an unrealistically large value. Let's try 3 meters. Going back to the model and pressing T, we can see that, due to the larger interior margin, a smaller part of the room is considered interior. Instead, most of the surfaces are considered as exterior walls. Let's put back the value we had. Now, let's change some wall types. Again, we can do this in the material list under the Type column. By default, walls are set as normal. For walls configured under this type, Odeon will decide whether to consider it as an exterior wall or an interior wall based on the current interior margin. If the surface was part of an object close to the wall, and we actually consider the object part of the exterior wall, such as a column or a window pane, then we'd had to set it as exterior. This will override the automatic classification of exterior versus interior. If we have a surface that is split into several small surfaces, usually the case for curved surfaces, then we would have to set it as fractional. The smaller a surface is, the more scattering Odeon will produce automatically. This is physically accurate for surfaces that are actually small, but it can produce too much scattering for a single surface that is split into smaller surfaces in the model. The fractional setting makes sure that the ensemble of surfaces is treated as one curved surface instead of separate surfaces. This produces less scattering, which is more realistic in this specific case. In this model, we have a dome, so we will need to use the fractional option to get accurate results. To configure all the curved surfaces as fractional, we will first select it for a single surface. Don't worry, you won't need to do this individually for every surface. Instead, you can scroll down to the last relevant surface, shift-click on it to select them all, and then click on the Repeat Wall Type button. This will take the first surface type in the selection and apply it to your whole selection. We can visualize the difference between the two settings by using the 3D billiard visualization. Then, we can adjust the view and set the radiation to YZ. This is a comparison of having the curved walls configured as normal versus having them as fractional, and it is easy to notice extra scattering when they are configured as normal. For the specific case of a curved surface that was split into many surfaces, the second one is the more accurate of the two. Otherwise, surfaces that are separate should produce more scattering. That concludes this tutorial, and we hope you have found it useful. Good luck!